Hello, my name is Emilio Antonio Tamayo Escorcia, and today I'm presenting my key activity on the subject of energy and transformation 2. The topic of my key activity is 2D vectors. So, the purpose of this research is to find if the direction of the vector can actually affect other variables such as the coordinates of the vector in the rectangular form, which means the ending point of the vector, where the arrow is, in order to apply it in real life situations. For example, when you are in your car trying to get to another place, which means your destination, you need to know the angle of your route in a Cartesian plane in order to get to that point. We can use this actually in a GPS system. So first of all, what are vectors? Vectors are quantities that have both magnitude and direction, which means that they have a value representing the distance a vector has traveled and a value that represents the angle between the object and the Cartesian plane. I'll go into details in the next slide. So the magnitude of the vector is what the arrow has traveled. It can be measured in centimeters, meters, or if it's a bigger distance, in kilometers. And they're represented by the length of the arrow, since the start of the Cartesian plane to the end. And the direction, which is the important one here, is represented by where the vector is pointing at, where the arrow might be. And it's also represented by the angle, is measured by the angle. And it is very important because the angle is regarding to our x-axis, or it can be also in our y-axis. This is why we need to have a Cartesian plane to do the measurements and compare the angle of the vector to this degree. I'm sorry, my slides are not changing. Yes, we are changing. The materials I use in this experiment include the following: a white cardboard, a red marker, a black pen, a blue pen, a red pen, a 60-centimeter ruler, a protractor, and 3 toy cars. On the left, we can see an experimental design I made at the beginning of this experiment. Here we can see we have a Cartesian plane, and we can see that in this quadrant, in this section of the Cartesian plane, we have the 3 vectors. They are equal in magnitude, which means their length is the same. However, the direction is the one that changes. Here we can see that they have a different angle, each one has a different angle, but they have the same length. But at the end, they end in different points because of that angle. My variables are the following. The independent one is the one that I control. So it's the angle of the vector and their changes. The dependent one is the one that is a resulting one. So it will be the ending point of the vector represented as the coordinates in a rectangular form. And the control variables are those that are actually controlled by me, but are the same in the 3 experiments, in the 3 trials, because they need to be in the same condition. So these ones are the initial position of the object, which is the center of the Cartesian plane, the velocity of the object, and the acceleration of the object. My results are these, the raw data. In the object I pushed in a 20 degree angle, the ending coordinates are the following: 7i plus 2.3j. In the 45 degree angle object, the ending coordinates are the following: 6i plus 6j. And in the 80 degree angle object, the coordinates are 1.2i plus 6.1j. Here we can see a little bit of my data gathering process. Here as I mentioned, I drew a Cartesian plane on a white piece of cardboard, and I push 3 toy cars with a different angle, which you can see there. I drew a different route for each car based on a different angle, which I actually measured with my protractor. But even though I pushed them the same distance and they three started in the same position, they ended in different positions because of the angle, because it was a different angle. And here we can see that they ended in different positions, even though they are in the same quadrant and they have the same length. Their angles, their magnitudes are equal. But look here, the angles are different. And finally, my conclusions. To sum up everything that has been stated before, I would like to say that the results are actually congruent with the scientific literature and the hypothesis, because they tell us that if we change the angle, the direction of the vector will change. Therefore, the coordinates of the ending point will change as well, even if the magnitude is the same, as we proved in the experiment and in the experimental design. In the future, I would like to make the same experiment, but with a little bit of an improvement. In this case, I used a white piece of cardboard, as you saw, and it was handmade. My Cartesian plane was handmade. I did it myself with by drawing the lines. But in the future, I would like to do it with a millimetrical measurement to make it more exact. And in the end, the results will be more exact. The coordinates will for sure be more exact if it's done in a Cartesian plane with millimetric measurements. Finally, here are the references, the sources I consulted, and that's all for my key activity project. Thank you.